Hi, I'm Chris, and thanks for tuning in to the Freelance Robotics YouTube channel. Join me today as we perform some welding, some plasma cutting, and some plasma gouging on the Blue Dragon Framework self-programming robotic system and showcase its manufacturing capabilities. We're using two different plate thicknesses today, 10mm and 25mm. The 10mm plate is being used as a test plate to refine our plasma cutting settings, and the 25mm plate has been pre-cut at 45-degree angles and joined together by a single root weld. So we'll gouge out the back of this weld to reveal and remove any cavities, re-weld the gouge channel, and start to fill in the 90-degree gap between the plates. Here's a few of our practice runs on the 10mm plates. We tested some straight and weaving gouges trained using a method called hand training, which I'll elaborate on soon. After removing the metal debris from the piece and cleaning it up with a grinder, you can clearly see the quality of the gouges produced by this hypertherm plasma cutter. We were very happy with how the plasma cutter performed on the thinner test plates, so we're moving on to the 25mm thick plates now. We're using one of Framework's training methods called marker training, which involves taking a colored paint marker and drawing on the part where you want the robotic system to operate. The robot will then perform a set of scans of the part, turn the scan data into a 3D mesh model, and self-program itself to perform the desired action. This is the robot performing a cold run in which it performs the action without turning on the tool. We programmed this operation with a slight weaving motion and made the path slightly uneven as if it was gouged by hand to show the whole process doesn't need to be performed by the robot. You can, for example, gouge out contaminated welds by hand and then use the Framework system to re-weld over the top, or vice versa. Take a look at the robot now performing its hot run. Again, we clear out the debris and grind out the gouged channel. If you look closely, you can see the cavities formed from the root weld connecting these two angled plates together. These impurities severely weaken the weld, and finding them emphasize the importance of this process. To avoid any blow through when filling the gouged channel, we're first going to add another weld layer on top of the root weld on the other side. We've moved the plate over to our welding framework system and will be showcasing how hand training works from scratch. First, we add a new part into the system, give it a name, select the correct work zone, work surface and table, and then click Train Part to get started. We can then press Scan Table to create our model. Once generated, we can view it on the screen and select the hand training tab on the right, train part, and that'll begin our hand training process. Hand training lets the user move the robot by hand into a set of desired positions, record those points, and generate either a straight, arc, or circular path between them. In this example, we are training only 2 points, one at the start of where we want to weld and one at the end. When the training process is complete, the path is generated on the interface and you can perform a simulation to validate the robot's path before attempting any runs on the real robot. Here's the cold run of this operation. You'll notice that the channel is very wide in comparison to the torch, so filling it will require a slight weaving motion. This can be added into the operation from the Pattern tab, and you can alter the frequency, amplitude, and delay of the weave. This is what that looks like. And we've also set the speed of the robot to 6.5 millimeters per second and our Fronius welding job to number 32. Here's the cold run of what that operation is going to look like, and here's the hot run. The weld turned out to look fantastic. Flipping the part back over to the original gouge channel, we can repeat this whole training process again, perform a cold run and then another hot run. Here's how that turned out. We've taken another one of the same parts and have performed marker training on it again. We have used another weaving motion, but this time we haven't adjusted the path at all. It is left completely straight. This will give you an idea of the kind of cuts and gouges you can expect from an accurate robotic system like Framework. Here's what the final gouge looks like. On the left is the linear marker trained robotic gouge path, and on the right is the altered path made to mimic what a human could achieve. You can see just how accurate and stable the system is in comparison. We then took this part over to our welding system, trained it using hand training, and filled in the gouge channel with fresh material. Here are the results. This is a great looking weld and it showcases the benefits of using a robotic manufacturing system for tasks such as this.